This is Chapter 4. It's types of chemical reactions and solutions for chemistry. This is Section 4.2, nature of aqueous solutions, strong and weak electrolytes. So a solution is a homogeneous mixture, which means it looks the same throughout. So both of these are homogeneous. They do have color, but they are the same throughout the solution. The solute dissolves in the solvent. It changes phase if it's in a different phase than the solvent. For example, NaCl, table salt going into water. Table salt's a solid, water is a liquid. It's present in the lesser amount if in the same phase as the solvent. So that's how you choose which is the solute and which is the solvent. Here's a picture of copper sulfate crystals. The dime's in there to give you some scale so you know how large they are. An electrolyte, you might remember testing for electrolytes in your first chemistry class. We have a battery going into the light bulb. The ions allow the electricity to flow between the wires. But you have to have a complete circuit for electricity to flow. An electrolyte is defined as a substance that, when dissolved in water, produces a solution that can conduct electricity. The solution's not producing the electricity, it's just that the ions can flow to the electrodes. We have strong electrolytes. You might remember they would make the light bulb light up quite strongly. And these strong electrolytes are salts. And let's go to this. So if we have a strong electrolyte, it says select a box to view the behavior of a strong electrolyte, weak electrolyte, or not.
Strong electrolytes dissociate completely to give ions in solution that conduct electrical current. Soluble salts, strong acids, and strong bases act as strong electrolytes in solution.
So notice it was pretty bright light.
Weak electrolytes dissociate to a small extent to give only a few ions in solution available to conduct electrical current. Weak acids and bases are the most common weak electrolytes.
We'll be talking about weak acids and bases ever so soon, and a non-electrolyte.
Non-electrolytes are molecular species that do not dissociate into ions in solution. There are no ions available to conduct electrical current. Molecular compounds like alcohols and sugars are examples of non-electrolytes.
So even though ethanol dissolves in water, it does not dissociate into ions, so it cannot carry an electric charge. So here's just an example of NaCl going into water. So you have all your ions. The ions carry the electric charge. So this would be a strong electrolyte. And you see a bright light. Strong acids. When you have a strong acid, it virtually dissociates completely. So we have lots of hydrogen ions. So for example, we have hydrochloric acid producing. It truly does produce hydronium, but we abbreviate it to just hydrogen, and chloride ions. So none of the HCl is left as a molecule. With a strong acid. So when you look in solution, it's all dissociated, which makes it a strong electrolyte as well. So some strong acids include nitric acid, HNO3, which dissociates completely, and sulfuric acid. Notice it's the first hydrogen that comes off H2SO3. One more time, H2SO4, sulfuric acid. That makes it strong. Strong bases dissociate completely, producing hydroxide ions. So these are your soluble hydroxides. If you could look in solution, you would see lots of cations of sodium, and there's your hydroxide. Weak electrolytes only dissociate or ionize to a small extent. So when you test it with a light, you're just going to get a very dull or dim light. So if you look here, you only have 2 ions All the others are molecules to represent the weak electrolyte. So a weak acid is acetic acid. We have this double-sided arrow to show it's in an equilibrium position, and when it dissociates, you only get some hydrogen ions and some acetate. Most of it stays as hydrogen acetate. It does not dissociate. 1% ionizes. So that's what acetic acid looks like. So, looking in solution, here you can see you just have a dissociation. There's your hydrogen ion, there's your acetate ion. All these others are molecules of hydrogen acetate that are not dissociated. Another weak acid is formic acid. And organic acid has that ending COOH. And formic acid will also ionize, but only to a small extent. It looks something like that. A weak base, one of the most famous, is ammonia, and it ionizes only to a small extent. So again, note the equilibrium arrow, double-sided arrow, and there's the ammonia molecule. So most of the ammonia is still NH3, there's no ammonium or hydroxide. And here's the representation of your ammonia. There's your positive ion, and there's your negative ion for hydroxide. Non-electrolytes don't produce any ions when dissolved in water. So we have ethanol as our example. It does not break up at all when it dissolves in water, so that's the representation here of the yellow spheres as the whole molecule of ethanol. It does dissolve because of the attraction of the oxygen in water and hydrogen and the OH bonding in ethanol, but it does not ionize. Sucrose in water is another non-electrolyte. Even though it dissolves in water because it has polar bonds, it does not ionize. None of the sucrose doesn't break apart to form ions. So it's a non-electrolyte.